Hello everybody, my name is Ricardo and I'm currently working for Infostellar, based in Japan, in beautiful Tokyo. And we are a company that we develop communication systems. We're currently focusing on ground stations networks for small satellites. And well, I'm here a little bit to introduce you our first project, Stellar Station, and to find out how we can help and support the CubeSat community. First of all, in the low Earth orbit environment, and later on, if possible, in more like longer distance missions, like interplanetary or similar things. So today we'll introduce the Stellar Station platform to you, and we'll also try to introduce what's our plan for our midterm goals in terms of constellation management with the current ground stations network we have. So a little bit about our vision. So this is a very general slide on the vision we currently have. So what we are currently doing is that we're currently providing Earth orbit communications, and we want to help in the growth of the CubeSat community. So currently this vision is kind of aligned with the products we're developing, in the sense of most of the products we have, like Stellar Station, have free of charge services for the CubeSat community, so that we can track your satellites, and we can also do a lot of passive ranging for the communications free of charge. So we want to be part of the community right now, and we want to help everybody in the CubeSat community to achieve our goals. And then we have planned a scenario in which around close to 2030, we can support deep space communications. And once the CubeSat technology is consolidated for these new challenges. So we're currently also speaking with people who have big antenna dishes, let's say 15 meters or something similar to that will be used for deep space communications. And we're currently actually finding out a lot of people who have these huge dishes that they're not using. So it's a great opportunity for everybody, but well, it still takes a lot of work. So we're just currently thinking on it. So this is a little bit our vision for the following years. So this is part of the team only. Currently we are based in Tokyo, and we are 23, I think. Yeah, kind of 23 people there. I'm the one in the middle. I work there as a senior systems engineer. And Naomi, I think that there's a lot of people who knows her. She's currently going to all the conferences. Actually, today she was going to be here, but she has gone to so many conferences in the last months and stuff that she kind of has an ache. Why don't you go there and I get some rest here. And then VJ, it's our business developer, and he's currently at SpaceOps in Marseille. Together with another member of our team. So, well, this is pretty much, this is the 3 people of our team that you will see more often in conferences. Well, this is it. So, what's a Stellar Station? So, the idea behind this first, let's say, product that we have in Stellar is that there's a lot of ground stations and antennas already deployed. So, a lot of people have those super valuable resources already deployed and with a huge operational capacity. But people is using them not a lot. So most of the times the ground station is perfectly operable and is well maintained, but it's only used maybe 40 minutes per day. The idea behind the Stellar Station is to support sharing those resources with more people. So that if you have a ground station or somebody else has a ground station, we have a platform in the middle that enables sharing those resources. So most people right now, they're creating a CubeSat project, they bring their ground station, they buy everything, they put it there, and then that ground station is kept there without a lot of usage. So Stellar Station aims at kind of allowing more people to exploit those resources. So the way in which we are considering Stellar Station, and for this we also would love to hear from the community, from anybody who has ideas on this vision, is that we want to enable this platform in the middle on the cloud that connects people, and through a credit-based system can allow people to use somebody else's ground station in exchange of sharing the ground And pretty much this is what we want to do with the Stellar Station, okay? So that we kind of like separate and split the ground station itself from the operations part. So how do we do it? Currently we have a bunch of people from Google. I'm really honored of working with all of them. They're like super great engineers. I have never worked with people from Google before. So we have guys from YouTube, we have guys that work at Google itself, guys who work as project managers at Google. And so what we are really good at is at all the cloud infrastructure that is necessary for making this happen, for making this platform in the middle that allows the sharing to occur. And so what we do in the middle is that we do all the antenna evaluation process, we do all the matching of the available resources together with the scheduling, and we handle all that so that we want to provide a simple WebSocket or gRPC socket interface through Google infrastructure so that operating your satellite is as easy as connecting your MCS to that endpoint and forgetting about the rest. That's our idea. Of course, there's a lot of technical challenges in the middle, but we want to hide all that so that connecting to your satellite is more a matter of opening a socket than a matter of, wow, I have to deploy all this ground station, it's going to take me 6 months. That's the idea behind it. Of course, it's hard. Nobody said it was easy, but we're working on that. So, the ecosystem we want to favor is this one. If we are in the middle and we have all these resources available, we can enable a way in which, either through credits or in a way of pay-as-you-go, more like a mobile phone-like, you have your ground stations available, although you have not deployed it yourself. So the way in which we look at it is that there's a lot of resources, and if we share them properly with a proper credit system, we can let people earn money by sharing the ground station, and other people get ground stations by just paying as they go. So this is a little bit an ecosystem that we want to start promoting, so that instead of you thinking about, I need to deploy my ground station, you think about, well, I can pay as I go because I need more passes today, or I need passes in a different location, or I need to download these images on the other side of the planet and I don't have a ground station there. So that's kind of the idea of the ecosystem we want to create. Aiming at this, at the cost-effective communication. Okay, so more rather than having like an all traditional way in which you ship your comms box to a remote ground station and you put it there in a big dish, you have a cost-effective communication in which you pay as you go, or you can share the ground station and receive credits for that. But as I said before, we also want to make the CubeSat community like grow together with us and together with these services. So we have non-commercial services, which will be mostly focused on the CubeSat amateur services. And for that, we are currently offering already through our web platform a passive downlink tracking, which is going to be useful through the build phase, and also as a tracking according to request. So if you have your CubeSat flying, you can just go to our website and tell us, hey man, can you track this satellite? And we are going to be all cool about that. So please do it, and you'll see that we can get your data and send it to you back. And also something we're doing is that during the ISS deployment, we are tracking all the CubeSats that are deployed. So as soon as the TLEs are available, we track them so that during that LEO phase, you are more than welcome to access our web platform and just retrieve all the IQ files with the information we have about the LEO phase of your satellites. And then we're also aiming at providing licensing or license assistance. So to deploy this ground station network, we became very aware of how complex it is to grant the licenses. So we're learning that amateur licenses look like easier, but in the end, commercial frequency licenses are very good, and they are not that hard at all. So if you ever had any trouble with licenses or the licensing process, just shoot us an email, and we'll be more than glad to help. That's for the commercial network. So for the non-commercial UHF network, which we try to base more on a pay-as-you-go or pay-as-you-use approach, we are deploying a UHF network first, which will have a bunch of ground stations, as you can see there. by the end of this year. We're currently this month deploying 5 new ground stations. So I think that by September it will be like a really good coverage the one that the network will achieve. So just access the link that you see over there to check out what our current web platform can do. And as you can see, we're focusing pretty much in understanding very well the signals we get from the satellite, like that little picture you have there at the bottom corner on the left of the slide. That's like the spectrum that we get out of boundary passes. We're analyzing like around 70 passes per day in an automated fashion, just to check signal quality, like SNR and gaps in the signal, for example. And well, this is something that we're doing to provide a good quality of service. And for the commercial services, we're going to start deploying our S-band downlink network in September. And next year, we'll have S and X-band uplink downlink capacities. So, as you can tell, in between this year and next year, Infostellar is going to have a network that is web accessible, it's easy to use in theory, and that you're more than welcome to start using. One of the things, and this is the main issue we want to present here, is that we want to provide extra services on top of the network. When you have an infrastructure based on Google infrastructure, it's just so easy to make new things, to add new software, to get into new frameworks, and to deliver new products. But what we want to do is that we want to aggregate a lot of new services, like constellation management, into the cloud. What's the reason? Because we believe that we can make it really easy to manage constellations. So, one of the things we're going to focus is on having a cloud-based scheduling. So pretty much doing a lot of automatic scheduling and automated balance loading. Right now, we are integrating 2 MCS from 2 different software providers into our network. So whenever we finish integrating them by the end of this month, you can see Infostellar not only as a ground station network provider, but as a network that already has a mission control software working on top of a set of ground stations. And on top of that, for next year, we're going to start doing automated scheduling and automated balance loading so that we can seamlessly and automatically balance the different operations over a network of ground stations. So I'm going to go really quick because I don't have a lot of time left, but the key here is integrating MCS software. So those of you who have an MCS software and are open to integrate it, we have a public API that is open source that we have released last week that you can use and anybody can use to integrate their MCS on top of our network of ground stations. The good thing there is that whenever we achieve that, we can understand the real operational status of the satellites and we can do a lot of things with that. If the satellite is in survival mode, we can prioritize the passes of that satellite over a set of ground stations automatically so that the telemetry of that satellite, or at least the beacons, are retrieved faster. If that satellite has been operating for 2 years in a row, we can reroute all the next operations through a different satellite or through a different set of ground stations. So the good thing of the cloud and the centralized network through the cloud infrastructure is that we have a single understanding of the whole operational status of network of ground stations and of a network of satellites. So that's what we are aiming with integrating MCS. And the last thing we want to do is providing an automated payload data delivery service. And once we have all this MCS integrated and we have the automated scheduler, what we want to do is allow people just to access the network and manage satellites as abstractly as possible. I know that this is a big endeavor because satellites are not easy to manage. So operationally speaking, a satellite that can get pretty complex, and in different situations, nobody's going to want to let the satellite work automatically. Having an operator in the middle that you can talk to is very useful. But definitely trying to automate for constellation management all these operations through network ground stations is one thing that the Infostellar want to provide. And well, and this is also, please join the network, access our website, and feel free to make any questions now.
Okay, any questions? Start with that. Yep.
This is a very interesting initiative, for receiving it's okay. For emitting, at least in France, we have a regulation. We are committed. So the operator of the ground station is committed to be at walking distance of the emitter when emitting. So have you faced this kind of constraints anywhere else, and how do you imagine to deal with that?
Okay, so we have been dealing with that for the last months, and I totally agree. Like, we are aware of that legislation. So there's two types of legislation here in place: the amateur legislation for amateur bands, which definitely requires that. Requires the operator of being walking distance, plus the operator needs to understand the list of commands to be sent to the satellite, plus it has to physically send them to the satellite, because the objective of amateur bands is doing amateur stuff. So if you want to commercially operate your satellite, you don't need an amateur frequency. I mean, you should get a commercial frequency. So for the amateur bands, we have a downlink-only network. So we have passive services that we can provide. And then if we have specific projects with people to address amateur projects on a per case basis. For commercial bands, it's a totally different game. So for commercial bands, we have agreements with local people in different countries. We get the right permissions for the transmission frequencies, and we get everything ready, and we even get the equipment certified if necessary. So downlink, I totally agree, it's super easy. Transmitting for amateur bands, it's not going to be part of our business, unfortunately. It might be a per case basis. And non-amateur frequencies like commercial frequencies, it's something that we're working with local partners, and we're making it happen. It's easier.
So I'm not sure I understood. What is the incentive for an antenna owner to accumulate credits? What do they get for this?
So the main incentive for an antenna owner to accumulate credits, especially if an antenna owner has a constellation. So if you have a single antenna, the connectivity or the operational capacity you have with your constellation is very limited to the capacity you have with your antenna. If you share that antenna with others, you earn credits by others using your antenna. And those credits can be used for you to use other people's antennas. And so you can manage your constellation more efficiently than if you have to wait for your satellite to pass only over your single ground station. Thank you. No problem.
What kind of security have you implemented?
All right, so this is actually the question that we are always asked for. We have all our web management system based on Google infrastructure. So all our services follow the regulations of the Google infrastructure and follow their security. On top of that, we can encrypt upon a request by the user the communications directly from the ground segment, from the ground station to the endpoint. So if users want to use the network in a more secure fashion, they can give us a public key. We can encrypt the comms with a public key, and they are the only ones who can decrypt that, as long as they take care of nobody getting their private key. So pretty much those are the measurements we have in place.
This question over here.
Well, the ground stations you're installing, how many spacecraft do they talk to simultaneously at one time? Are they tracking stations or are they?
Yeah. So if you have one tracking station, so we're deploying something I didn't explain. We're deploying two types of ground stations: the sharing station and the co-hosting station. The co-hosting station is our own hardware that can only track one satellite at a time. But in shared stations where people already have their hardware there deployed, there's some cases in which they have several antennas. So we are working with people on a per case basis to actually support several channels, if possible, with the resources that are already deployed.
Any further questions? Sorry, there's a microphone to your right.
So you were mentioning S-band. Do you have any plan to move to? Sorry, you were mentioning S-band, right? So any plan to move to X-band or even K-band?
Yes, sorry if I didn't make it clear enough. Like this year we're going to do S-band downlink, but we're working on our own SDR radio to support as many modulations as possible. So that SR radio is going to be common for X-band too. So this year we're going to focus on really nailing down that S-band radio, and next year we're going to start deploying S and X at the same time. Potentially we need to explore KA band, but we want to focus on small satellite community, which right now is more demanding on services for S and X band, in our opinion.
Any further questions?
Sorry, I should have asked this one last time. So you have amateur and you have commercial bands. What about the CCSDS science bands?
CCSDS?
Yeah, the science applications. For big space stuff.
So right now I'm not really aware of us having any activities on that. But do you mind if we talk after this about it? Okay, thank you.
Any further? No, well, thanks again.
Thank you.